We're going to spend a few days looking at multiple representations of linear relationships. So we're going to look at 4 or 5 situations today in class, and then you're going to finish the rest. And then, like I said, we'll spend a few days on this type of problem. All right, so let's take a look at the first type of problem. So in each, you can see each page is split into 4 parts. There's a description, an equation, a table, and a graph. And you're given one of these, and then from the one, you're going to have to figure out the other 3. So in the first situation, you're given the description. From the description, can you figure out the equation, the graph, and the table? So the description says at North Parking Garage, it costs $5 to bring your car into the garage, plus $2 for every car that is parked.
Jamie LaPrey, please call 6123. Jamie LaPrey, please call 6123.
All right, so let's start with an equation. We've done these before. So we have y equals, and if it's linear, we have y equals mx plus b, where b is the y-intercept, the starting value, and m is the rate of change or the slope. So it costs $5. That's our y-intercept here, so I'm going to put a $5 plus $2 for every hour the car is parked. So 2 would be our slope for every hour. So if we define our variables here, hours is going to be x, so x is the number of hours. We'd multiply that by 2. And then the charge is how much we pay, so that's the y value. So now we're going to use this to fill out our table and also make our graph. So I'm going to move this down. So again, if we just go to the parking garage, it's $5, and then it's $2 every hour that we stay there. So 5 plus 2 is 7. 7 plus 2 is 9. We have 11, 13, and 15. So here's our table right here. And then we're going to graph those values right here. Should I move this down a little bit more? All right, so when we graph it, we have to figure out like a good scale to use. So x is the hours and y is the cost. I'm going to put that, the independent variable, or hours, x always goes along the bottom. So this is number of hours. And then the charge, I'm going to put right here, charge. And again, if we look at our table for hours, we have to go from 0 to 5. And from charge, we have to go from 5 to 15. So I'm just going to start at 0. I'm just going to go up by 2s. 12, 14, 16, 18, 20. And then hours, it's just 5 hours. So I'm just going to go every other one is 1 hour. 1, 2, 3, 4, and 5. Let's graph so we can see for 0, it's $5. For 1 hour, it's $2 more, 7. For 2 hours, it's 9. For 3 hours, it's 11. For 4 hours, it's 13. And for 5 hours, it's 15. So we can see what this looks like right here. And we've gone from our words to our equation to our table and our graph, and that's what we're practicing today. Let's take a look at the next situation. So in this one, we're not given the description, but we are given the equation, and from that we can figure out everything else. So if you look at the equation, it says cost equals 10 cents times the number of texts plus $50. So if we write a description, I'm going to say that our phone plan is $50 a month plus 10 cents per text. So then we can figure out right here, I'm going to make this smaller here. So if there's 0 text, we're going to plug in 10 cents times 0 plus 50. So it's going to be $50 if we don't text. But if we have 100 texts, that's 10 cents times 100 plus 50. And 10 cents times 100 is 10. 10 plus 50 is 60. If we do 10 cents times 200 texts, that's 20. 20 plus 50 is 70. And you can see these are going up by $10 for every 100 texts. So I'm going to say this is 80. This is 90, and this is $100 if you do 500 texts a month. Okay, now to graph it, and also to figure out our slope, so I'm going to erase this guy right here. All right, so to get the slope of 10 cents a month, because we see it's going in our table, it's going up by 10, but our slope isn't $10, our slope is 10 cents. Here's how you can figure out slope. You're going to look at your change in y and your change in x. So again, here's our change in y and our change in x. So from 50 to 60, it's going up 10, and from 0 to 100, it's going up 100. So to get our slope right here, it's rise over run, and rise is our y value. So to get that 10 cents, they're doing 10 divided by 100 to get the 10 cents. So again, if it's not going up by ones for the x value, you have to find your change in y and divide it by your change in x. All right, let's graph this. Here we open this. And again, when we graph it, we're going to put our number of techs, our independent variable, our x variable, on the bottom, and we'll put our dependent variable on the side, and our dependent variable is charge or money. So this is number of texts. And this is going up by 100, so I'm just going to say every other one is 100. We'll start at 0, and this is 200, 300, 400, this is 500. And here I have to go up to $100, so I'm going to go by 20. So this is 20, 40, 60, 80, 100. And again, here were the amounts that we had that I erased. So again, it costs $50 if we do no text. If we do 100 texts, it's $60. 200 texts, it's $70. And then $80, $90, and $100. Okay, so that is going from the equation to all the rest of the three forms. Let's look at if we have description tree, growth versus years, and now we have the table. All right, so let's start with the table right here. Again, notice we have our x value as years, our y value as height. This is not going up by ones. This is going up by twos. So to figure out the slope, we have to do rise over run. So if you know from 8 to 10, that's going up by twos. It's going up by twos every year. So the slope is rise over run, which is 2 over 2. So our slope is 1. So we have y equals our starting value is 8 plus 1x, or put 8 plus x. So this is our equation, and we got it by looking at rise over run and our y-intercept. And we can make the description. We can say that our tree is 8 feet tall, and it grows 1 foot a year. So there's the description. 8 feet tall, grows 1 foot a year. Let's make our table. We have to go from 0 to 20 years, so I'm going to go up by 2's. And our height has to go from 8 to 28, so I'm going to go up by 4's. So if we make our graph right here, so this will be years, and this will be height. And again, I'm going to go by 2, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And our heights, I'm just going to go by 4's. 4, 8, 12, 16, 20, 22, 24, 28. Okay, so 0 is 8 feet, so 8 feet's right here. At 2 years, it's 10, so that would be right here. And I have at 4 years, it's 12. Oops, I did my dot wrong here. Let's try that again. At 10 years, it's 18. At 16 years, it's 24. Here's 24. And at 20, it's 28. Do that right? 10 is at 18. Yep. Okay, so you can see it looks pretty linear here. All right, so we just went from the table to the equation. We didn't do the description, but we can say the description. Oh, I think we did the description. Yep, okay. All right, so we did all 4 forms. Let's look at the last situation, and this is miles traveled versus hours. And this time we have the graph. So let's go from the graph to the table to the equation. So let's go graph at 0 hours, 0 miles traveled. At 2, or at 1, it's 50. At 2, it's 100 miles traveled. At 3, it's 150. And at 4, it's 200. And at 5, it's 250. So if we do the equation, we can say it starts at 0 and it's going up by 1s and it's going up by 50s here. So our slope is 50. Every one that it goes up, every one that it goes over, it's going up 50. So let's make our equation. Would be y equals 0. So I'm not going to write that, plus 50x. And we can say you're traveling at 50 miles per hour. Okay. All right, so for your assignment, you're going to do one of each of these situations where I give you one, either the description, equation, table, or graph, and you have to come up with the other three representations. And one that I think we'll do in class together is the pumpkin weights one. Again, just looking at the slope. So the y-intercept here is 0, but the slope, notice it's not going up by 1s. This one's going up by 5s. And the weight in pumpkins is going up by 8. So here the slope is rise over run. And again, it's change in y, which is 8, over change in x, which is 5. So our equation would be, we start at 0, but our slope is 8/5 x. Okay, so this was day 1 of multiple representations. We're going to spend a few more days on this, and by the time you take the test, you should be comfortable going through each form.